For question 15, we're going to expand this x plus a x plus b squared. So after we expand this, hence, they come out of working hence, means we will use our expansion here to find out what is our value a and b when our expansion is equals to x cubed minus 3x minus 2. So after finish that part, we're going to express this fraction into a partial fractions. So for the first task here, we're going to expand out x plus a and x plus b squared. So for x plus b squared, we're going to square it, x squared, and then 2ab become 2bx, and then b squared. Then we're going to expand one by one, where x expand with x squared, x cubed, x with 2bx, 2bx squared, and then continue x with b squared. Then for a, expand to the back, ax squared, for a to the 2bx here, and then for a to the b squared here, and then we were going to start collect our terms. For x cubed, we only have one terms, but for x squared, we can see here is our x squared, here is our another x squared, so our terms will be 2b plus a for the x squared coefficient. Then for x, so for x it will be b squared plus 2ab, and then x. So lastly, constant is ab squared. So this is our expansion from this x plus a and x plus b squared. Hence, so I will use this expansion compare with equals to this. So compare our expansion with x cubed minus 3x minus 2. So what can we compare? For x cubed, they are same. For x squared, it don't have. When it don't have, means we can conclude that the coefficient of x squared is 0. So that's why we don't have any x squared. So means this constant is 0. For x, it is negative 3. So means that here b squared plus 2ab equals to negative 3. And the last one, constant value, ab squared equals to negative 2. So from this comparison expansion, we have to find out what is our value a and b. So we are going to form two simultaneous equations. From here we have three information, so we're going to use two simultaneous equations, which I selected the easier equation so that we can solve it. So I will select this first equation where I will let a equals to negative 2b, and then I will choose this equation. So this will be our second equation. So when we want to solve two unknown, two simultaneous equation already enough. So we not necessary to use up to three equations here. So we are going to start solving our simultaneous equation by substitute equation 1 into 2, where a equals to negative 2b. So we can notice that here is negative 2b cubed equals to negative 2, b cubed equals to 1, so b will be cube roots of 1, which will equals to 1. So once we get b equals to 1, we will substitute into 1 to get a, which is negative 2. So that will be our first task. So for the expansion here, we get 1 marks to show that we know that how to expand. And then when it equal, we come out the comparison of this coefficient. There will be 1 marks. And then we start solving our simultaneous to get our answer A and B. Then we have to express this fraction into a partial fractions. So notice that our denominator here is already equals equals to this part because they say expand this equals to this. So means that from our first task just now, x cubed minus 3x minus 2 can be equals to x plus a and then x plus b squared. So that will be our denominator part in factorized form. So we're going to start to do our partial fraction. Our first step in partial fraction, which is we need to identify this fraction whether proper or improper. So we can see numerator is in power of 4, denominator is in power of 3, which is cubic. So we can notice that our numerator ranking is greater than denominator. So this fraction obviously is an improper fraction. So for improper fraction, we have to undergo long division in order to get the proper part, to express the proper part into the partial fractions. So we're going to do our long division now to find out where's the proper part from these fractions. So we need the multiplier of x so that we can get x to the power of 4. Then for the rest, we expand. So x with 3x, negative 3x squared, and then x with 2 will become negative 2x. So we can see what is our balance here. This one minus equals to 0, negative 4 minus negative 3 will become negative x squared. And then here, negative become positive. So we can see our remainder here is x squared. Our divisor here is x cubed. So we cannot proceed our long division because our remainder is smaller than, the ranking is already smaller than cubic ranking. So from here, we can write our improper fraction into a proper fraction form. Divide by the divisor in factor. Our quotient is x, and then our remainder here is negative x squared plus 7x minus 1 over x minus 2, x plus 1 squared. So this is the proper fractions, which will we undergo to express it as partial fractions. So after we done our step 1, then we double check our step 2, divisor also in factor form. So we start our partial fractions. Take the remainder part, which is the proper part, and split it into factor. So we have denominator factor x minus 2, and we have repeating factor as you see here, x plus 1 square means they are repeating x plus 1, x plus 1. So for repeating concept, we will write it for x plus 1 for the first time, and when it repeats, it will become x plus 1 square. So after we determine the factor and split according to the factor, then we will continue determine the numerator here. For a linear factor, numerator will be a constant. For a linear factor, numerator will be a constant. So this is a repeating linear factor. Linear factor up here will be a constant. So for the next step, we build out the equation by equal the numerator part, where a need to times with the factors it don't have. So the complete factors we can see here, the complete fraction is here. So this is our partial fractions. So we can see the complete fraction here, it need to time with x plus 1 square. For the b part, they need to time with x minus 2 and then another factor x plus 1. For c, it will time with x minus 2. Then we're going to using this equation to solve our ABC. So since we have 3 unknown here, means we need to let it 3 times. So let the x become the roots value. So we can see our roots value, we can see our factor here, our roots value will be equals to 2. And then our x value can be equals to negative 1. So another x value can be randomly choose the number that we easier to calculate. So I choose value 0. Then we start substitute the numbers. Here we become negative 4, then negative 5, then plus 14, it become 9. Then 2 we put here, 3 square, 9a. 2 we put here 0, 2 we put here 0, so we get a equals to 1. Continue for another x value, x negative 1 here will be equals to negative 9. And then when we substitute here, negative 1, 0, negative 1, 0, here, negative 1, negative 2, together negative 3, c. So c divide, negative 9 divided by negative 3, we get 3. So lastly, we put substitute 0 here, it will get negative 1. So we use our a, we already found, which is 1. So 1 square, which one b, then negative 2, 0 plus 1, and then c is 3, negative 2, find out our b value here. So negative 6 move here, plus 6 will equal to 5. 5 minus 1 will equals to 4. So our b here will equals to negative 2. So finally, when you want to substitute back our ABC here into the partial fraction, we have to start from the improper fraction here. So go back to the original question, which the improper fraction there. And write the quotient x and the proper fraction which already expressed in ABC. So where our a is 1, x minus 2, b is negative 2, so negative 2 per x plus 1. Then c is 3. So we will substitute this partial fraction in the remainder part here. So this is how we express an improper fraction into a partial fractions. So therefore, the most important concept when we doing our expression into partial fraction, the first one will be our first step. How do we get proper fraction from improper fraction, which is the concept of long division. To count out this answer, then only we can, to count out this answer, then we can see this is the part that will be going to express in partial fractions. And then concept of building out the equation and concept of let it 3 times in order to find ABC and the answer of them. So the first answer is going to obtain A and C. Second answer will obtain the B. Lastly, you still need to express back to the origin questions here. So 1, 2, 3, 4, 5, 6, 7. 8, 9, 10, 11, 12. This is how we score our 12 marks.